we go. All right, so 9-3 is multiplying matrices. So in 9-2, we did scalar multiplication, but that was just taking a matrix and multiplying it by a constant. So now we're going to take two matrices and multiply them together. The key concept here kind of shows the rules, where you take the rows from the first one times the multiply the terms by the columns, and you add up. And I know this is kind of confusing, the way this is shown. So I will explain it when we get down here. But first we need to discuss, can matrices even be multiplied together? Okay, so if you know the dimensions, if you're taking a 2x5 matrix times a 5x4 matrix, it can be multiplied together if these inner dimensions, so the columns from the first matrix, equal the columns of the second matrix. Or equal the rows. Columns of the first matrix equal the rows of the second matrix. So this is determined whether this product is defined. This one is defined. And you can just write a little note if you want for your notes that the inner dimensions must equal. If they are, the product is defined. Which means we can find the product, okay? But it says, the directions say then, if so, state the dimensions of the product. Well, first you check those inner dimensions. They're the same. So if they are the same, then you just take these outer dimensions, and that is your product. So you'll end up with the dimensions in your answer of a 2x4 matrix. So if we look at number 2, we needed to first figure out, can I even multiply these together? Look at the inner dimensions, the columns from the first one, the rows of the second one. 3 and 4 do not equal, so the product is not defined. And therefore, we can't do it, so we won't have a final matrix that has a set dimensions. So now we're actually going to multiply some matrices here. Now these are square matrices, so dimensions are going to be the same, 2 by 2, 2 by 2, but always double check. So the dimensions here, 2 by 2, 2 by 2, these inner dimensions have to be the same, okay? So I know my answer will give me a 2 by 2, it'll equal a 2 by 2 matrix, okay? All right, so what we do is, and then I kind of give myself some space here. So I'm going to take, well, here, I didn't want to use red. Okay. So I'm going to take the first row from my first matrix. Okay, I'm in the first row of my answer here, and that first row of the first matrix is 2. I will take it times something, and then the second number in the row is -1, and I'm going to take it times something as well. Okay, that's that first row of that first matrix. And I'm in the space. Let's color code this a little bit. This is the first column. So we take the first column of the second matrix. So first row of the first matrix, first column of the second. And that column has a 3 and then a 5 as you go from top to bottom. Okay, we go left to right for the rows. We go top to bottom for the columns. So I took this row, this column. Okay? That will give me the first term in my solution. So I'm going to go ahead and do the whole first column of my solution. So now I'm in the position of the second row. So I'm taking the second row of the first matrix. So I get 3 multiply it by something, and then plus 4 multiplied by something. Well, that something, it's still in that first column. So I'm still taking it times that first column of the second matrix. So I have a 3 and a 5. All right, so let's move to the second column here. So now I'm going to do the second column. I don't know what I did. Okay. So I'm still in the first row of my answer. So I'm still taking that first row of the first matrix, which is 2 times something plus a -1 times something. Well, that something we're going to multiply by is the second column of the second matrix. So it's always the rows from the first, the columns from the second. And I'm always going to keep repeating that so that way you don't forget. -9 and 7. Okay. I move down to the second row, so that means I need to use the second row of that first matrix, which is 3 and 4. And I'm still in the second column, so I use that second column of the second matrix, -9 and 7. And that's it. I've used my rows and columns there, got my 2 by 2, and we multiply things together. So let's just see if I want to do this. This would be a 6 and a -5, they add up to a 1. Ooh, that was weird. -18, -7, adds up to a -25. Let's see, 9 and 20, so that's 29. -27 and 28 would be 1. Whoa, I wrote that weird. Okay, there we go. So this is my 2 by 2 matrix. That is the solution of those two matrices multiplied together.